What's up, everyone, and welcome. In this episode, we're going to talk about Chinese espionage, a new Win32k driver 0-day, and rats. As always, we'll recap the story and see what we can take away from this event so we can integrate it into our own security strategy. So sit back and enjoy, and don't forget to subscribe if you haven't already, and smash the bell if you haven't already, and like this video, of course, and share it with anyone you know that actually can benefit from this information.
Oh, drat these computers. They're so naughty and so complex. I could pinch them.
A Chinese-speaking hacking group exploited a 0-day vulnerability in the Windows Win32k kernel driver to deploy a previously unknown remote access trojan, or rat. The malware, known as MysterySnail, was found by Kaspersky security researchers on multiple Microsoft servers between late August and early September 2021. They also found an elevation of privilege exploit targeting the Win32k driver, security flaw tracked as CV 2021-40449, and patched by Microsoft as part of this month's Patch Tuesday. Besides finding the 0-day in the wild, we analyzed the malware payload used along with the 0-day exploit and found that variants of the malware were detected in widespread espionage campaigns against IT companies, military defense contractors, and diplomatic entities, Kaspersky researchers Boris, Larin, and Costin, Raiu said. Code similarity and reuse of command and control infrastructure we discovered allowed us to connect these attacks with the actor known as Iron Husky, a Chinese-speaking group with activity dating back to 2012. The Chinese-speaking Iron Husky app was first spotted by Kaspersky in 2017 while investigating a campaign targeting Russian and Mongolian government entities, aviation companies, and research institutes with the end goal of collecting intelligence on the Russian-Mongolian military negotiations.
I'll see what the little stinker is up to on my super video detecto set.
1 year later, Kaspersky researchers observed them exploiting CVE 2017-11882 Microsoft Office memory corruption vulnerability to spread rats typically used by Chinese-speaking groups, including PlugX and Poison Ivy. The privilege escalation exploit used to deploy the MysterySnail rat deployed in these attacks targets Windows client and server versions from Windows 7 and Windows Server 2008 all the way through and up to the latest versions, including Windows 11 and Windows Server 2022, if they are unpatched against CVE 2021-40449. While the 0-day exploit spotted by Kaspersky in the wild also supports targeting Windows client versions, it was only discovered on Windows Server systems. The MysterySnail rat is designed to collect and exfiltrate system information from compromised hosts before reaching out to its command and control server for further commands. MysterySnail can perform various tasks on infected machines, ranging from spawning new processes and killing already running ones, to launching interactive shells and launching a proxy server with support for up to 50 simultaneous connections. The malware itself is not very sophisticated and has functionality similar to many other remote shells the two researchers added. But it still somehow stands out with a relatively large number of implemented commands and extra capabilities like monitoring for inserted disk drives and the ability to act as a proxy. The exploitation process for this vulnerability is as follows. First, a user mode call to reset DC executes syscall nt GDI reset DC and its inner function GRE reset DC internal. This function gets a pointer to a PDC object and then performs a call to function HDC OpenDCW. The function HDC OpenDCW performs a user mode callback, and it can be used to execute reset DC for the same handle a second time. So it basically just goes through that process until it can be executed successfully. Now, if an exploit executes reset DC during a callback, NT GDI reset DC and GRE reset DC internal are executed again for the same DC. So again, they're just trying it until they can get it to work. Now, if an exploit ignores all the callbacks during the second call to the GRE reset DC internal, this function will be executed as intended, meaning it worked, so it doesn't need to be run again. Now, it will create a new DC and then get rid of the old one that the PDC object is destroyed. So the PDC object would get destroyed. Now, in the callback, after the second reset DC call has completed, the exploit can reclaim the freed memory of the PDC object and finish the execution of the callback. After execution of the callback, function HDC open DCW returns to GRE reset DC internal, but the pointer retrieved in the step 1 is now a dangling pointer. It points to the memory of the previously destroyed PDC object. Finally, in the late stage of the GRE reset DC internal execution, a malformed PDC object can be used to perform a call to an arbitrary kernel function with controlled parameters.
Now, like all great plans, my strategy is so simple an idiot could have devised it. Checkmate.
Now, as mentioned earlier, before receiving any commands, the malware gathers and sends general information about the victim machine. Now, this information includes computer name, current OEM code page or default identifier, the Windows product name, the local IP address, logged in username, campaign name, etc. Now, in total, the rat implements 20 commands. Their descriptions are as follows. There's a launch interactive command.exe shell. Before launching the command.exe, it is copied to the temp folder with a different name. Spawn new processes via console. Get existing disk drives and their type. Now this function also works in the background, checking for new drives. Create or upload new file. If a file exists, append data to it. Get directory list. Kill arbitrary process. Delete a file. Read the file. If the file is too big, async read operation can be stopped. Reconnect. Set sleep time in milliseconds. Shut down network and exit. Exit. Kill interactive shell. Terminate file reading operation. No operation. Open proxied connection to provide a host. Now again, up to 50 simultaneous connections can be established. Send data to the proxied connection. Close all proxy connections. And close the requested proxy connection. So, we have a new rat. We have vulnerabilities of the Win32k. We have Chinese espionage happening on countries and governments around the world. So, what did we learn? Again, the amount of attacks we hear about in the news and newfound threats like these underlines for me the old tip of the iceberg adage. For every one we know of or learn about, there are probably 5 or more that have yet to be discovered. What we could specifically take away as learnings from this event is that we should be doing things like scanning the temp folder for new executables being added to the temp folder. We can theoretically check various fingerprints of these files dumped into the temp folder, maybe use file size or creation date, and we can also monitor the launching of applications from the temp folders with alerts to sysadmins when this occurs. Now, if possible, we can look at ways to lock down the ability to even launch apps located in the temp folder, or located outside of known and approved of locations like program files or x86 program files folders, etc. Additionally, we can monitor PowerShell and command logs to look for suspicious activities like kill commands, or opening up of shells, or the creation of or copy commands. These could all be scanned within the PowerShell or the command line log files in real time, monitored, so that we can catch them as early on as possible. Now, that's if they're already on your system. Ways to protect yourself or your systems from even allowing them to gain access includes many of the tips from all of my previous episodes, like better security of your SSH, RDP, and TeamViewer or whatever remote control application using multi-factor authentication, patch, stay up to date with your patching, all these types of things. Now, we can also use our system firewall to lock down outgoing connections, at least on servers, to only known endpoints like Windows Update servers or other internal systems where they're required. So, there's plenty to learn from this story. There's plenty that we can review in our internal processes, our security processes, to see if we're taking this kind of attack or this kind of exploit into account within our processes and our monitoring. So, with that, I say thanks again for watching. Don't forget to share and subscribe if you haven't already, and smash the bell if you haven't already, and I'll see you on the next episode. Take care.